Okay, welcome to this video. In this video, we'll explore ionic bonds and electrolysis. First of all, what are ionic bonds? And to understand what they are, first we need to take a look at this periodic table I have here. Now, you see these first two, hydrogen, helium. Duh, they just act normal. Helium is a noble gas. It doesn't want any electrons, they're just free floating atoms. Hydrogen is just going to grab one extra electron, sort of like a halogen, and to become a whole molecule. However, the numbers 3, 4, 11, 12, 19, 20, 37, 38, 55, 56, 87, and 88 on the periodic table act different. Everything you see here that is purple colored in different shades of purple is an alkaline metal, and everything you see here in different shades of green is an alkaline earthed metal. Here's the difference. If you take this whole sea of atoms I have here for some reason, when they come in contact with other atoms, alkaline metals usually give off one electron, and alkaline earth metals give off two. This has a big difference on the structure of molecules formed by these atoms, which we'll explain later. First of all, let's imagine table salt to understand ionic bonding. No, not two sodiums. Okay, you'd usually imagine NaCl, aka table salt, halite, or rock salt, is structured like this. But I can tell you that's all wrong. So take that understanding and dump it. So, really, since sodium wants to give up its electron, it gives an extra electron to the chlorine here. So the sodium becomes positively charged, and the electron gets trapped into the chlorine atom, and it becomes negatively charged. And positive and negative charges, basically different charges, attract. So NaCl becomes a whole molecule which can actually form crystal structures. So, what about the alkaline earthed metals? For example, let's take magnesium hydroxide. With our understanding of alkaline earth metals, you'd imagine magnesium hydroxide might be this. A, that is false. The magnesium will give an electron to the oxygen, and the oxygen will become negatively charged. However, this is also false, because magnesium is an alkaline earth metal, and it wants to give off two electrons. So, it gets more. So, if you drop a block of magnesium into water, it just gathers the water, and it turns the water into hydroxide, as you can see here, with the negative charge by giving off its electrons, and then the free floating hydrogens just group together and form hydrogen gas, which is going to be pretty explosive by the end. Now, here's for the fun part, electrolysis. Say, for example, you've an aqueous solution of rock salt, or I should say sodium chloride. Well, imagine we just have these nice little water molecules floating around, and we also are eventually going to add some rock salt. And remember, it's Na plus and Cl minus. Now, what happens is when you apply an electric charge, normally if you use something like magnesium salts or Epsom salts, and the hydrogen would be looser, so it'd snap off the hydrogen and form hydrogen gas and oxygen gas. However, in this case, something special happens. the chlorine is going to be stripped off easier, so the chlorine is actually going to leave the solution, and it's going to turn into this free-floating chlorine gas. When I actually did this, I kind of saw something that looked like hydrogen, though most sources say it's chlorine, so I'll go with it. And then, as you know, the sodium reacts with the water, and you lose the extra hydrogens, and then the sodium just gets pulled over. Like you lose your hydrogen. You lose your hydrogen and another hydrogen as the sodium passes its electron, and then you get sodium hydroxide along with some extra hydrogen gas. I guess that's where I was getting all the clear gas. Instead, as the electrolysis process happens, you can get rid of all the extras, and you just have sodium hydroxide ready to make soap. But really, it is pretty cool. However, if you just have magnesium salts, let's imagine the magnesium salts are out of view for now because it's really hard to memorize the full crystal structure or something like that. Let's imagine the magnesium salt is just swirling around. When an electric charge is applied, the hydrogen and the oxygen are gonna break apart, and it's gonna become this. The hydrogen, which were bonded to the oxygen, become gas, and then the other two hydrogens, and then the oxygens bond together. The hydrogens will go to the anode, and the oxygen will go to the cathode. And then, if you really wanted, you could bring up a flame, and it would react with the oxygen in the air and burn, and it will produce some water vapor. But I would not recommend that. So, that's it for today. And always remember, stay safe. And if you really want to do electrolysis of aqueous NaCl, which is not recommended because of the chlorine potential in NaOH, wear gloves. Bye.